Pretty mean.
So your graph should look something like this, right? So we've got them intersecting, right? Does everyone see an intersection on their graph?
Yeah.
What quadrant is that in, though? Yeah, remember quadrant 1 and then counterclockwise. So this is quadrant 2. My x value is what? What does x represent? My input, right? The years, right? So am I going to run, are they going to have exactly the same amount of food as they do in negative years? Is that going to be the answer? No. No. So this is going to be a curve too. So this is a very broad curve, right? So what we need to do is zoom out. We want to see, apparently these are going to intersect 2 times. So to do that, we got to zoom out of this graph to see the intersection point. So where it says window right here, you should press window. And I don't need any negative numbers here. So what's my x minimum? I'm just going to leave that at 0. This represents what am I seeing on the screen here. So the x minimum can be 0. The x maximum, though, we're going to use 100. What do you guys think this means? XSCL. How much you're going by, right? This is my increments. So if I do increments of 1, there's not going to be any tick marks. It's just going to be 2 solid lines. So what we're going to do, we'll do increments of 10.
How did you do it?
I'll just press 0.
Oh, yeah.
Yeah, so if you want to change this, if this is negative 10, you can press clear, and 0, or just press 0. And our x scale, excuse me, we're going to use 10. So we're going to see increments of 10 here. Decades, right? We're talking about our x scale is 10. And I don't need negative population. That'd be silly. So y minimum is 0. And y maximum, we're going to say 100. So does that mean 100 people? What does that 100 stand for? How many people? Shelby, my graph goes all the way to the y maximum 100. Does that represent 100 people? 100 million people. So we're talking, this is all in terms of millions. We just saved ourselves the effort of saying 0.5000000x plus 4,000,000. And our y scale, we want to change that to 10 as well. And then press enter. And we're going to press graph again. We're going to see what we get now. Is everyone on board here? Now this looks like an exponential growth function, right? We can see the curve this time. I can see the curve. See it? All right. Is everyone on board here? Does everyone see this on your screen?
Yeah.
I got confused.
Totally got yours.
What did you do yesterday? What did you do yesterday?
Got it? All right. So when are we going to have the exact same amount of food as we do people? About how many years would you say? Before we find exactly. About 8. 1, 2, 3, 4, 5, 6, 7, 8. 8-ish. What does that 8 mean? How many years? 80 years, right? And then this would be how many people? 1, 2, 3, 4. 4-ish. Between 4 and 5. What does that 4 represent? They're by 10, right? So this is 40 million people. All right. All right, guys, stay focused. I know we've been working on these calculators a while, but to figure out the exact point of intersection, you're going to see all these buttons right here. They have instructions on the top. This would be statistics plotting, table set, format, and calc. That's what we want to do. We want to calculate something. So to get to calc, I don't want to press trace. Well, I do want to press trace, but I want to get to the second command, so I'm going to press second trace. And guess which one we're going to do here? Intersection, yes. So go to 5. And don't do anything after that. Because it's going to say first curve. Why is this, excuse me. Yes, go to 5 and press enter. And follow along. And we've been doing this a while, but this is kind of cool, right? We're using calculators. We're finding exact points of intersection. This is going to intersect, this curve is intersecting this line twice, right? So we expanded this curve. This curve is going to approach 0 but never touch it, right? What is that called?
I know.
A funny word. Starts with an A. Close. Asymptote. Asymptote 0. So I know that this is intersecting, this curve is intersecting our line twice. That's why it's saying, what, first curve? Question mark. So, and you see a little pointer there. So with the keypad here, you want to go move it over so it's close to the intersection. That would be good enough. This has to be closer to one intersection over another. And so one of our lines we've got over here. So then you press enter when you're near that intersection point. That's what we want to find out. And then the second curve, make sure that's over there as well. You can move this one around too. And then guess. Well, we're getting an exact amount. That's our estimate. Somewhere over there.
Wait, if it says first curve, you press.
Just enter at the bottom. So make sure that this little scroll that you can move is close to this intersection. And then when it says guess, just press enter again. And you guys should see this. So now I want to ask, how long is it going to take for them to run out of food in this imaginary country?
I'll give it a year.
Not a year. How many years is it going to take for them to run out of food?
78. 43 years? No, 78.
78 years. What happens at 78.3 years? That'd be like 78 and 3 months. It'd be like March, 78th year. What's happening at this point? Charlotte, how would you describe what's happening at this point? There's 43 million people. It's been 78 years. Mr. B's still around, teaching math. 78 years later.
We're all scrawny.
I got robot legs by now, okay? That's scrawny. Have more robot than man, but still teaching math. Yes. What's happening at this exact point? Come on, guys. We're almost done here. Carolea, what's happening at this exact point? What's the relationship between food and people? Huh? Life. Zombies? Yeah. Apocalypse? Apocalypse is coming. What is at this exact point though? How much food is there? How many people can eat? 43.16 million. How many people are there? 43.16 million. So there is a symbiotic relationship between the food supply and the people, meaning there's just enough food for people. So they're not running out of food in 78 years. When are they running out of food? What happens after this point?
Yeah.
People are starting increasing, right? Food supply isn't increasing fast enough. Now we might maybe not have zombies, like Dwayne said, but Philip might be right. Apocalypse is coming, right?
Yeah.
Because people can't eat. People get rowdy and fight. I don't know. Bad things are going to happen. So when are they running out of food? Kyron, how many years, if I want to round to the nearest year, when is there not enough food for people? 79 years, yes. That's a while. What about 80 years? There's even less food, right? People, there's bigger gap. Soon enough, they're going to have to figure out how to farm on the moon.
Cannibalism.
They're going to invade another country to steal food. All right, we're almost done here. So number 3, in approximately what year will this country first experience shortage of food? 79?
Yeah.
Is that what I'm going to write? Year 79. What is the year that it is from the beginning, though? Remember, write that down. 2016. What is 2016 plus 79? Quick way to figure this out. 80 plus 16 would be 96, right? But this isn't 80, this is one less. It would be 95. 20, 95.
Yeah, I'll be dead.
No, you won't.
I'll be old.
There's another factor. How is population rate increasing as to life expectancy rate is also increasing. That's going to affect population growth, right? More people living longer. All right, what I want you guys to do is answer number 4 and 5. Using this graph, you're going to need this graph for 4 and 5. Leave that on your computer. Your calculator. Let me see what you got. Answer number 4 and 5. All right. If a country doubled its initial food supply and maintained a constant rate of increase in supply adequate for another 0.5 million people per year, would shortages still occur?
Yeah.
Yeah. What are we really doing if we double the initial food supply? What changes from our equations? Are they both curves? No. What is changing there? The people. If a country doubled its initial food supply, what am I changing from my function? Press y equals. Oops, turn it back on. Y equals here. What do I change out of here? 0.5? No, that's not changing. Constant rate stays the same. The exponent. Wait, what's changing though? Am I changing y1 or y2, first of all? All right, let's read number 4 again. The country doubled its initial food supply and maintained a constant rate of increase in the supply adequate for an additional 5.5 million people per year, would shortages still occur? So am I changing y1 or y2? The country doubled its initial food supply. What am I changing, y1 or y2? Food supply, right? That's our linear function, so I'm changing y1. What do I change there? It even says right there, pretty explicitly, 0.5 million people per year. Explicitly means like right in front of us, right? Straightforward. So 0.5 is not changing. That means one other thing has to change. Yeah, we're starting off, remember the original question says, we've got enough food to 4 million people initially. It's saying initially we're doubling it. So what does this 4 turn into? 8. And then we're going to press graph again. What happened to that line? Language. Thank you. What happened to this line? I changed the y-intercept. It's parallel to the original line, right? If I just entered in y3 as our new function, it would be parallel. All that we really changed was how much food they start out with. Same amount increasing every year. So we can just figure out what that point is, and we'll know the second part of this question. Because I can tell that they're still running out of food at some point. So we're going to go back. We're going to figure out the intersection again. Everybody ready? Second, calc. 5 for intersect. Now I want to scroll over to this intersection. Told you we were doing cool stuff today. Second curve. That's close enough too. Am I guessing? No. Computer's telling me. I'm going to press enter anyway. So really, by doubling their initial food supply, remember this is a curve that's going to get increased more and more, quicker and quicker. So all we did was just give them another 3 years before they start invading other countries, turning into zombies. So after 81 years, we had 79 here, so I would just add 2 more years. Yes, it would still occur. When? 2097. Or excuse me, 2092. 98. Jeez. Brain fart. All right, so what you guys, we got 5 more minutes. Do number 5 on your own and then turn it in right here. And I'm going to come around and help you guys make sure you get number 5 right. And give the projector a rest. Good job today.